One more problem from the electric circuits, and we have to find out the potential at A. So we have to find out the potential at A point if we know potential at B. So in this problem, the potential at B point is 0 given. So the potential at B point is given 0 value, and we have to find out what is the potential at A point. So if you want to solve this type of problems, and we have to know the sign convention rules for the KVL, and I have to explain first of all, then go for the this problem solution. Okay, now. So if you go, for example, in the circuit we have battery at cell. So this is my symbol of the battery at cell. If you are entering, so if you solve any type of problem in the circuit, you may prefer direction either clockwise or anti-clock. For example, if I entering into the positive terminal of the battery, that EMF, for example, it has 2 volts is there, and when you entering into the positive terminal of the battery, this EMF we have to take it as a negative. We have to assign minus, that is a minus 2 volts. Otherwise, if you are entering into the negative terminal of the battery, that EMF of this battery you can take it as a plus 2 volts. Okay, this is about the battery at cell. And go for the resistance. In the resistance we have so many circuits. In the circuits we have so many resistors are there, and this is my resistance R. Okay, so this is the current and the resistance in this direction, and the sign of the voltage across the these resistance depends upon the our direction and the current direction. For example, if you go along the current direction, the sign of the voltage drop across the resistance is negative. V is equal to minus of voltage drop across the resistance, that is the current in this element I, and value is R, minus I into R. Okay. Next, otherwise, if you are entering, so this is the direction of the current in the resistor, and also if you are entering, so we are going opposite to the current direction in the resistance, and we can assign the sign is plus I into R. So these are the rules we have to remember to solve this type of problems. Okay, so we go for the problem, right? So we have to find out what is the potential at A point if you know potential at B point. Okay, what is the potential at B point? So he has given 0. Okay, now we are going to go from A to B. So which is higher potential? So your current is coming from A to B, or not? Now this is higher potential, is lower potential. Current is always flowing from higher potential to lower potential. Now we have to apply KVL from A point. Higher potential, this is a rise. So I can take VA, the potential at A point, VA, and so it is my direction. I'm going from A to B, and there is now what is the current in this element in this direction, which is along my direction or not? That's why we can take sign of the voltage across the resistor is minus I into R. What is the current in this element? I resistor value 2. So 1 into 2, and also we are entering into the positive terminal of the battery. So we can assign the sign is minus. So how much voltage here? How much EMF is there? Minus 4. And also we are going along the current direction in the resistance. The sign of 3 ohm is a minus. So 3 into the current element is 1 ampere into 1. 3 into 1, and lower potential we can assign minus VB and is equal to 0. What is the KVL? Algebraic sum of the increase and decreases voltages across elements. All elements in a closed path is equal to 0. That's why I can assign 0. Okay, now I want to solve for VA. VA and minus 1 into 2, minus 4, minus 3, and minus VB. What is VB value? 0 equal to 0. Now VA is equal to minus 2, minus 4, minus 6, minus 6, minus 3, minus 9. If you bring that side, this is the 9 volts. So the potential at VA is equal to 9 volts. Okay, students. So this channel మీకు ఉపయోగపడుతుంది అనుకుంటే, and subscribe and share it, and if you want to see full videos, and subscribe my channel. Thank you.